today I'm gonna be solving this problem, 1043 partition array for maximum sum. I solved it yesterday, and now I'll try to reproduce the solution. So let me check what the problem statement is about. So the bounds constraints are not that high, so I can even do like n squared approach. If you're gonna do n squared, it's gonna be like 25k, oh no, like 250k max operations, like, so it's still optimal, like within seconds of program execution. So let me just figure out like this array. So we have Ri, then 1, 15, 7, 9, 2, 5, 10. And in a DP array, it's gonna be, I'm gonna store the max, largest sum if current sequence, so DP of I, if current sequence ends at I. So in this case, so let's save DP, and DP gonna be, so initially the max sequence gonna be 1, so I'll store 1. So for the next index, there are a couple of options. The first option, I'm gonna start, so like I can either have a sequence of length 1 and then add whatever I have for the previous result. So it's gonna be 15 plus DP 0, or I can expand 15 to the previous item. So it's gonna be 15, 15, and the sum gonna be like 30. And I need to select maximum here. This one gonna be 15 plus 1, so 16. So in this case, the maximum is 30. So let's check out, and k is equal 3. So let's check the next value. So 7, like the current AI is like 7. And there are again a couple of options. The first option is I'm gonna use just length of like current sequence gonna have the length of 1. In this case, the result gonna be the max so the largest sum gonna be if the current sequence is length of 1, gonna be 7 plus DP I minus 1, and gonna be 7 plus 30, and gonna be 37. Or I can figure out like whatever like is was the greatest element, like if I check the sequence, so it's sequence len equals 1. If sequence len equals 2, then I need to check what the greatest element for that sequence that ends at I, and then I need to kind of multiply that by the number of elements, and it's going to be 15 by 2, it's going to be 30 plus DP I minus 2, it's going to be 30 plus 1, it's going to be 30, no, 30 plus 1 here, yes, it's going to be 31. Or So it was a sequence length equals 2. And then the next one gonna be sequence length equals 3. It's gonna be just a length of 3 here. And then dp I minus 3, but I minus 3 is actually out of the bound, so it's going to be just this greatest element in a sequence of length 3 that ends at I multiplied by 3. So it's going to be 30 by, no, not 30, 15 by 3. And it's going to be 45. And then I need to select the maximum in this case. So maximum between 37, 31 and 45 gonna be 45. So I enter 45 for the dp index 2, 6. Or even let me just do this. So 0, 1, 2, 3, 4, 5, 6. So next one, dp of 3. So dp of 3 gonna be equal. So again, a sequence length 1 is gonna be dp plus dp 9 plus dp of 3 minus 1 gonna be 45. So it's gonna be 54. If length is 2, is gonna be 9 by 2 plus 30. It's gonna be 48. If length equals 3, it's gonna be 15 by 3 plus 1. So gonna be 46, and then that's the maximum I can go because I can have maximum length of 3 for the current sequence that ends at the current index. So it can be like this sequence, this sequence, and this sequence, and then I cannot go in further. So in this case, the maximum gonna be 54. And I recorded here, and so on and so forth. So for the next one, dp of 4 gonna be max between lengths 1. So I'm currently here. So it's gonna be 2 plus 54, or it's gonna be 9 by 2 plus 45. So it's gonna be 56. That's gonna be 18 plus 45. So 18 plus 45 is gonna be 50, 60, 63. 1, 2, and then length 3. Gonna be, so the largest in the sequence that end of length 3 gonna be 9. Gonna be 9 by 3 plus 30, and it's gonna be 9 by 3 gonna be 27, 57. In this case, the largest one is 63. So next one, dp of 5, and then length 1 gonna be 5 plus 63, gonna be 68. Length 2 gonna be 10 plus 54, gonna be 64. Length 3 gonna be 9 by 3 gonna be 27 plus 30 equals 57, and also 68. and the last one dp of 6. So len 1 gonna be 10 plus 68 equals 78, or len 2 20 plus 63 83, len 3 30 plus 45. Yeah, might be some mistake here, but like the answer here is 84, but should actually be 80. I have like 83, but it should be actually 84. So I'm not sure in what number. It should be not. So for this one, it should be 20 plus 54 actually. Yeah. Ten plus 68. No. Yeah, I'm not sure about this number. If I'm not sure about this number, it means that it should be like this. Oh, okay, so here 30 plus 54 should be the last one. So it's gonna be 84, and then here 84. So it should be like this. I messed up a little bit order. And so the result gonna be the maximum between all DP numbers. So it's gonna be 84, and the output should be 84. Result equals 84. So what's the time complexity for this one? So the time complexity for the every kind of sequence, for the every I need to go back k times, like, so that I check like sequence length 1, sequence length 2, sequence length and up to sequence length 3, or like sequence length k. And I need, then I do some calculations and look up. So it's basically gonna be for every I have k ops, and I have like n i's, and it means the total time complexity is gonna be O of n by k, and the space complexity gonna be O of n, because I need to store this DP array. I can probably optimize it like to have like max O of k ops. Oh, O of k, not ops, my space complexity. Yeah, so let me program this one. So I have this int n equals r length. What I have about time? You mean length, and I have this dp array, new int n, and then for int I. So I have say int I equals 0, I less than n, I plus plus, and then I'll have for int, so let's say I'll have like int largest equals 0, and then like greatest, because because they talk about greatest here. Okay, so the greatest one gonna be like 0 now, and then I'm gonna go from I equals 0, from j equals 0, j less than k, j plus plus, and then I'll do greatest equals max greatest and current. So Ri, and then the int max gonna be 0, and then max equals max max, and then greatest multiplied by j plus 1 plus, and then I want to check if the I minus j minus 1 greater or equal 0, then dp I minus j minus 1, otherwise 0. And then I want to update dp I gonna be equals max, and then int global, let's say res equals 0, and then res equals max res, and then dp of I. And then I will return res. So that's gonna be it. Let me run it. No. Where is the error? I know. So like greatest, so here I minus j. I minus j greater or equal 0, otherwise 0. No, still not. Okay, let's do this step by step. So it's failing for the first case. Okay, let's print out the greatest one. So system out print. Okay, so initial greatest one, okay, max one, greatest one, max. Okay, greatest is not updated somehow. It's always okay. Ah, okay, so the gonna be if k if j, okay, if I mean minus j less than 0, I'm gonna break. This one should be removed. Okay. Yeah, minor mistake. Okay. What if I gonna save, if I gonna have linked list or something like that, or like queue. Can I get a queue element at index in Java? Yeah, it might be too. Because I need a kind of sliding window, so I need to somehow efficiently update it, and yeah, I don't know, because I tried to think about like reducing the space complexity to O of k, but it requires doing this sliding window approach for the current window of size k, and I need also efficiently to access the element in this sliding window. Yeah, I know. So I can claim it's a fail because I had one error there. So that's it.